Dear distinguished professors and guests, have a pleasant morning to one and all, and happy Teachers' Day wishes to all. Dear teacher, thanks for inspiring hope in me, igniting my imaginations, and instilling in me a love of learning. And happy Teachers' Day to all the participants. And we are in the second day of International Virtual Conference to share our ideas and discussions. Let's begin the day with these cherished words. If you can't fly, then run. If you can't run, then walk. If you can't walk, then crawl. By all means, keep moving. Said by Martin Luther King. Next, we move on to the invited talk. For that, a winner is a dreamer who never gives up. Let me welcome Dr. R. Palaniyappan sir, Associate Professor in Research Department of Computer Science, VHNSNC College, Srinagar. He also acted as Controller of Examination and Coordinator of SF programs. He did MCA, MPhil, and awarded doctoral degree in computer science. He has 31 years of teaching experience, in which 10 years for his research. His area of specialization is handwritten digit recognition using compression-based cluster classification and ALN. About his professional teaching, he attended orientation course in Bardiyar University, Coimbatore, and 3 refresher courses in JNU, New Delhi, and Madurai Kamaraj University, Madurai. Dr. R. Palaniyappan sir attended 4 international level conferences and published 6 papers at national and international levels. Under his guidance, 12 MPhil scholars completed their degree. He is a member in various academic institutions such as Madurai Kamaraj University, Ayanadar Janakimal College, Sivagasi, Standard Pyrox Rajaratnam College, Sivagasi, B.B. Vanniyapperupal College for Women, Virnagar. He was the recipient of Best Teaching Staff of the Year 2018 in VHNSNC and Best NSS Program Officer of Madurai Kamaraj University in 1998. Dr. R. Palaniyappan sir held various positions in our college, such as NAC Steering Committee Member and Coordinator in 2013, NAC Steering Committee Member in 2007 and 2019, and Boys Hostel Chief Warden in 2006, and Senior Faculty Member in IPAC. He acted as root level trainer for hand pump maintenance and rural sanitation, and also acted as an external expert in SFR College for academic and administrative audit on 2019. I would like to request Session Chair Dr. R. Palaniyappan sir to introduce Mr. Kanaswamy Umapati, Senior Director, HCM Cloud Operations, Oracle USA, Incorporation, California, and United States of America. Sir, please.
Thank you, ma'am. Thank you for your very big word and introduction about me. Really a very good day to meet all of you because it's our day, the day that we are celebrating ourselves and the people who groomed us to this height. Many people have involved in grooming us, and we term them as teachers. So, a respectful day to our teachers who have brought up to this level. Teachers' Day wishes to all teachers and also to the teachers who are going to come in the future. And I thank the organizing committee for deputed me a task of introducing a very important person, Kanaswamy Umapati. Very happy to introduce her because today's world is mainly dependent on cloud technology, and the cloud technology shortly is ruling the world now, because we should be exposed to larger amount of details related to cloud and cloud related technologies. In this regard, he is the right person to session this important day in our international virtual conference. An important aspect that is being conducted by our college, very novel aspect conducted by our college, bringing in academicians around the globe to make them aware of different distinct concepts in science, technology, humanities, arts and science. Remarkable challenge that has been undertaken by our college. Hats off to our principal, management and Professor J. Kumaran for to have taken this task. eminently and taking to a very big scenario VHNSN to the globe. The task given to me is to introduce our eminent person, Thiru Kandasamy Umapati, our scientist Kandasamy Umapati sir. He did his undergraduation at University of Madras, that is Bachelor of Electronics and Communication Engineering. Thereafter, he did his post-graduation at Bharatiyar University, Master of Computer Science and Engineering. Thereafter, in the year 1995 to 1998, he worked in Mahindra British Telecom, Senior System Analyst for a duration of 3 years. Thereafter, he became Senior Consultant in Tech Edge Corporation and he worked there for a year. Then he took charge in Oracle. As Director Engineering IT Division located in California. He led a team that hosted and supported Oracle applications, EBS, Fusion, Siebel, PeopleSoft, JDE, and technology products, database, middleware, data integration, identity management for Oracle engineering teams. And he worked there for as a director engineering for 12 years and 6 months in this cadre. Thereafter, he was promoted as director enterprise information technology in Oracle. He led a group that provides data services to support applications used by Oracle customers and Oracle customer support. Additional responsibilities include analytics, secure enterprise search and communities, and he served for a duration of 1 year in this post. And from that, he has been given the charge of now he is in the post of Senior Director, HCM Cloud, Cupertino, California, for the past 8 years, right from 2012 to 2020. Is responsible for the management of HCM software as a service, cloud data quality, HCM cloud lifecycle management operations, HCM cloud on-premise data integration, HCM cloud diagnostics, HCM cloud monitoring. As a senior software professionals with extensive experience in hosting applications and technology products in private, public, and hybrid cloud, such an eminent personality should be the right person for this international virtual conference. With wholeheartedly, on behalf of VHNSN and the Pearl Foundations, we extend a very hearty welcome to you, sir, and I hand over the session to you and make this forum more exposed to cloud technology. We are all waiting to hear to you, sir. Welcome you, sir, and folks, please lend your ears to you, Kandasamy Umapati. Very, very important technology to be known today. Thank you so much. Thanks to the organizing committee for giving me the chance. Thank you so much.
Thank you so much, Dr. Palniappan, for the kind introduction, and thank you so much, Dr. Jayakumar, for inviting me, and Dr. Prem Shankar, who helped me set up the conference now. And thank you so much for all the kind words. Today, for the next hour or so, I would like to share my experience on cloud computing. The way I'm going to divide the next hour is, first 45 minutes, I would like to present on cloud computing in education. And then the last 15 minutes, I would like to focus on Q&A. If you have any questions, please reserve that. And we will go over all the questions at the end. And during this 45 minutes, I would like to introduce what is cloud computing, why we need to go to cloud computing, what are the different types of cloud computing out there, deployment models. In education, how the cloud computing is going to help us. And I'm going to divide that into rural education, higher education, research, and all the resources that are available for both teachers and students. So that's how I'm going to divide the next hour or so. Hopefully you all enjoy. If you have any questions, or if we are going out of context, please remind me so that we can come back to the topic and then continue. Okay. With that, let's get started. What is cloud computing? Let me go to the presentation mode. Let's get started. What is cloud computing? So it's not an academic definition, but there are loosely defined characteristics of cloud computing that we need to qualify in order to call a computing solution as a cloud computing, right? The first one, running workloads over the internet in a commercial provider's data center. So that is the first characteristics. So when we say workloads, any computing that we do, it may be a data processing for administration or for a research project or whatever the workloads that we have. So this is the term that you will hear very often called workload, right? Basically, that is nothing but computing, data processing, image processing, and all of them qualify as workloads. So you run the workloads via the internet. The keyword is internet. If you are running locally, then that's not going to qualify, right? So running workloads over the internet in a commercial provider's data centers. So who are the top commercial providers we have? We have Amazon Web Services, and then we have Microsoft Azure, Google as Google Platform Cloud, and we have IBM and Oracle Cloud Infrastructure. So these are the top cloud providers at the present. And of course, Amazon has the major market share, followed by Azure. Those are the top two, and Google is slowly catching up with both of them, right? So the first characteristics for a computing to qualify as a cloud computing, our workloads should be run on any of these cloud providers. So it need not be restricted to these five. There are other players like, you have, Adobe Cloud or Alibaba Cloud, and there are plenty of clouds out there. So it has to be on one of the commercial providers' data center, and we need to run the workloads out there and then consume the results over the internet. So that's the first characteristics. The second one, the resources that are in the commercial data center, commercial providers data center, has to be virtualized pool of resources. There are two keywords here. One is virtualized, the other one is pool of resources. So pool of resources, so we have more than 160, 170 resources that are included in cloud computing, but we are not listing all of them here. We just list the top ones. The first one is compute, storage, network, and data applications. So you have plenty of resources out there. I'm not going over all of them, right? So take these top five. So these are the pool of resources. Let's take compute. For example, you have a computer, right? So you have your CPU cores. That's what they call compute. So it's a resource, but pool of resources. It has to be a pool of resources. That means it has to be multiple computers, multiple cores of CPUs, right? The same thing with the storage. It's not one storage device. It has to be pool of resources, pool of storage devices. Even if you have one server, right? One storage server or one network, if we can virtualize them into multiple, right? So it has to be a virtualized pool of resources. Otherwise, it will not be called cloud. Let's say, like, you have a physical server, and then you're trying to host something even on the internet, then that's not going to qualify as a cloud. It has to be pool of resources.
It has to be multiples of these, multiple networks and multiple storage devices, multiple compute. So it has to be pool of resources. Then it has to be virtualized, meaning you take a physical computer and then you can create multiple VMs on that. So you can take one storage device and make it look like multiple storage devices. You can take one network, you can create multiple virtual private networks. So it has to be virtualized and it has to be pool of resources. If your commercial provider, cloud provider, has resources, pool of resources, which are virtualized, then that will qualify as cloud. Is that all? No. There are a few more characteristics that we need to be worrying about. The next one is this pool of resources has to be given to the consumer on an on-demand basis. Okay, here again we have two keywords here: on-demand and self-service model. On-demand meaning, hey, you're not going to book for a resource, right? Okay, on so-and-so date, give me 10 cores of CPU and then 2 terabytes of storage. You know, you're not going to reserve them. As and when you need it, you should be able to get it. You go log into your account, ask for 10 CPU or ask for 1 petabyte of storage. It should provision you on demand. So that's another characteristics. If a provider cannot provide you resources on demand, then that's not going to qualify as a cloud. Let's say, like, you take a classic hardware vendors. You order a compute device, they deliver to you. That's not cloud computing, right? So it has to be on demand. You log in, you ask for, 10 cores of CPU and 1 terabyte of storage, you will get it on demand, right? So the next one is self-service. It's not only on demand, I should be able to do it myself, right? There are no administrators sitting there. You pick a phone, call them, I want 10 CPUs and 1 terabyte of storage now, and they go and push a button and then that provisions you those hardware or software, right? So it has to be self-service. I go log into the cloud and then I request 10 CPUs, 1 terabyte of storage, and some software applications, right? Let's say, like, I want a database, right? MongoDB, or I need some other metric tool, right? So whatever I want, so I order some hardware resources, some software resources on demand in a self-service model. There is no human beings connected to this. On the application, the cloud admin page, we're going to go and request for this, and then it is going to provision. So that's the third characteristics. So the next one is elastic. It has to be elastic. What is elastic? So let's say, like, today I'm a startup company or I start a school, right? I want one computer and then 10 terabytes of storage. And then I want some office applications like a word processing or spreadsheets or, some data processing applications. So I buy them. Tomorrow, I grow and then I have 2 schools, 10 schools, right? Or I start a college. The same thing for a startup company. I do a startup, I come up with a web portal, news aggregator, or whatever it is. The next day it becomes big, right? I become a million user website. People come in. So whatever I got it on the day one is not going to work for these kind of expansion. So our businesses will grow As we grow, the IT infrastructure should also grow. So it should not be the case where, hey, I bought one computer and then some storage. Now I have 10 schools. This is not enough. I want more. So here, we're not going to go and ask them, hey, I'm placing another order. You add these things to this, and they take some time to provision those. Then it will not qualify as a cloud. It has to be elastic. So either I should say, like, expand this to 20 cores, or expand this to 1 petabyte of data or storage, or I want a ERP software instead of small business applications, right? So it should automatically provision those things on demand, and it has to be elastic. So on demand is one thing. The elastic, it has to be expandable. So the cloud vendor or provider cannot come back and say, oh, I don't have the space on that rack, so I need to move you to another data center. If they say that, then they are not a cloud provider. It has to be elastic. It has to auto scale per demand. So I'm going to say, today I have 1,000 students in my school, right? So tomorrow I have 10,000 students in the school or college. It has to expand to that computing need. So that's what we call elastic, right? So the no human intervention happening, not on the business side or the institution side going and requesting I need more, and then it gets provisioned. It is the auto scaling. It is automatically scaling, right? So see, some of these characteristics were not there initially, right? Whatever the way they started, a lot of people started as not an elastic cloud. So they called elastic cloud itself as a type of cloud. But now they're putting more and more stringent requirements to qualify a cloud as a true cloud. It has to be elastic. Okay. So, and so all these are good. We have, it's all good so far, right? We have virtualized pool of resources. It all runs in some commercial providers data center. We access them via internet. They give you only the URL. You just click on the URL, you get all your application running, and you're using the application. Everything is good, and then your business grows, your institution grows, and it auto scales, right? It scales without even we knowing about it, right? All good. Everything is looking great, right? But now somebody has to pay for this. So if somebody has to pay for this, it has to be measured. It has to be measured, like how we consume electricity, how we consume water, how we consume our mobile data, right? So similar to that, it has to be measured. The consumer has to be billed, right? So it has to be measurable. So the service that they provide a compute service or storage service or software service, whatever it is, that has to be measured. Some examples: compute, it is easy to measure. They give you 2 cores, 2 cores per month, this much dollar, right? And then 10 GB data or 2 TB data or whatever it is, or the number of, if it is software, number of users using the software, if it's a HR software or financial software or whatever it is, right? So the number of users using the software, right? It has to be measured. So I'm only giving few examples here. There are a lot of, as we said, these pool of resources can be anything. There are 160 plus resources that the resource types that are out there, right? So each one will have one or more measurement type. So in order to a computing solution to be called cloud computing, it has to satisfy these criteria. So the key, I have highlighted some of the keywords here. Our workloads should be running on somebody else's data center. So call them commercial cloud providers, and we should be able to access them through internet. The cloud providers has to pool these resources. They cannot dedicate a resource. If I buy it, they connect one computer to me, then that is not a true cloud computing. It has to be pool of resources. I will not even know which server I'm connected to. It's all virtualized. It may not be even one physical server. It may not be even one network that I'm connecting to. It will be virtualized, or it will be multiple network, and I'll be connected to one of them. Right? If there is something that's wrong with that network, I'll automatically be switched to another network. If there is a problem with that compute resource, I'll be automatically switched to another compute. That is the reason why they are insisting on pool of resources, and that needs to be virtualized as well. If it's not virtualized, if it is physical, if we make a connection, if they are making you to switch to another resource in case of failures, then you will incur a downtime. Okay, so that is why it has to be virtualized. It has to be pool of resources, and there are other reasons why they would like to do this virtualized and pool of resources. It can be shared across different consumers. The resources are shared as well. That's where the cloud is cheaper when compared to the on-premise solutions. We'll come to that in later slides. So then it has to be elastic. It has to be measurable. It has to be on a self-service model, no human interaction. It has to be on demand. And so of all these things, there are key enablers here. We need to keep in mind if you want to take key takeaways from this slide is it has to be virtualized, it has to be elastic, it has to be metered, meaning it should be measured. That's another reason why they call this as a utility computing, like your electricity, right? Like your water. You use as much as you want, right? You're not telling the electricity board, I'm going to be using extra electricity this month, right? You just consume it on demand, self-service. You consume it. You're not telling anyone. You consume it. It is elastic, right? So that's why we have another name for this. It's also called utility computing. Okay, so we saw what is cloud computing. Now, hey, why cloud computing? Everything is going fine. I have my on-premise. My college has a data center. My college has a IT department. Or if you are a business, your business, you may be a healthcare business. You may be a financial services business. Every business has a data center. Every business has an IT department. Everything is running fine. Why do I need to go to cloud computing? Why do I need, everything is running fine? Why do I need to go to cloud computing? Right? It is, I can answer that question in one word, right? Or I can go through all these bullets, but I will give that one word answer first and then elaborate. Simply, it saves money, right? Everything else is secondary. Simply, it saves money. If someone is going to tell your management, if you're a college, you're telling your management, someone is going and telling your management that, hey, there is a solution out here. If you move to that solution, it is going to save you 50% of the cost, right? If you are a business, right? If you are going to reduce your IT cost to 50%, So the business will definitely, your CFO or financial um, um, managers, they're going to be saying, oh, why can't we go to this technology, right? But that is not the only reason, because when they sell it, they'll always sell it uh, with this point, which is saves money. But that's not the reason why we need to move to cloud computing. There are a lot of other reasons why we should move. So let's go one by one. Pay as you use. So this is the one that we were talking about on utility computing, like your electricity, right? Consumption-based cost model, right? You consume it, however how much ever you're consuming, they're going to charge you for that, right? So no upfront capital expenditure. So I gave this example of if you're starting a school or a college, if you're starting a startup company, right? You don't have to buy servers. You don't have to buy servers. You don't have to buy storage devices. You don't have to buy network. You don't have to buy data center. You don't have, the data center has to be set up with the cooling, right? Lighting, and you need to pay the rent for the data center. You need to hire all these resources. For compute, you need to hire system analyst and system administrators. For storage, you need storage admin. You have network admin for network. You need and then the people to maintain your software, right? You need all these people cost as well. So hardware and software cost, right? You cannot be buying all of this on the day one. On the day one, you have 5 employees in your institution, maybe a college or maybe a business, right? You have 5 people there, right? You will buy small set of hardware. You still need to have all of these. Even if you have 5 people, you need server, you need storage, you need network, you need somebody to manage all of these, right? Even if you're hiring 2 people, right? So you need all of these on the day one. So a lot of upfront cost is involved. So they in the IT paradigm, they call CapEx, capital expenditure, right? So we are not paying everything upfront. We don't have to have any capex at all to start with. We can start on the cloud from day one, right? So the next point is also related to the previous one, smaller barrier to entry. So I don't have to have that much money to start a startup company. I can just go on to any of these commercial providers. They all give trial period, right? And also they give a free stack. If you're starting a company with 5 people, the free stack that you get itself is more than enough to get on, right? And if you're lucky and if your company is growing, then it is going to auto scale, right? So smaller barrier to entry, no commitment. Tomorrow, if if you go on to AWS, Amazon AWS, you don't like it, you want to move to another cloud provider, or you are shutting down your company, right? Hey, for this season it's not working, I need to wait till the next season to try this business. So you can shut it down. You can shut it down and leave it there, and you will not be billed. You will be billed zero. You're not using it. Or these are provided as containers. You can take the container and take it out and move to another cloud. You don't like Amazon, right? You want to go to the Google Cloud or Microsoft Azure. You can take the container and move it to another cloud, right? So there is no commitment. Commitment in terms of the vendor lock-in or the cost. There are no contracts like, we will use your service for 1 year, right? We will use your service for 2 months. It's not like that. You just go in there. Most of the cloud vendors, they charge you per hour basis. That's one price model, depending on what computing resource that you're um, you know ordering for. right? So there are cloud providers like Microsoft Azure. They even bill per minute. So there are no commitments. There are no long-term commitments, right? So you will be billed per minute. There are providers, they bill per hour, right? And there are providers, and depending on what you are subscribing to. For example, if you take software, you are billed per user. You are using a software. There are two people logged in, right? You'll be charged for two users. You shut it down. You change the password. Nobody is logging to your application. You'll not be charged anything. Either you can shut it down or you can lock it down. It will not be charged. So there are no commitments. A better cost per use. It's all related to all the costing model out there. The lower total cost of ownership. So we talked about the cost of hardware, and then maintenance is much easier. We don't maintain at all, right? We just order and then they maintain it. They maintain the server, they maintain the software, right? If there is a problem with the server, they fix it. If there is a problem with the software, they constantly patch, upgrade. We will not even know when they are doing it. And maintenance. Have you ever seen like Google going down for maintenance, or you know your Gmail going for maintenance? We will not even know when it's going for maintenance because of the virtualization they have at a highest level. You will not even know how they are maintaining it. They are doing all of those behind the scene using virtualization, right? So the maintenance innovations are spread through a multi-tenant infrastructure. So innovation, when we say innovation, there are new features. Let's say like, hey, this particular CPU is obsolete. There is a new CPU that came out, and then that needs to be replaced. If you own your data center, if you own your own IT, and you need to be doing upgrades. Same with the software. New versions, new features, you need to buy new version, right? Or upgrade. But none of that we are going to do. They are going to be constantly upgrading, constantly maintaining it behind the scene. We will not even know. They will say, hey, the hardware that you are using has been upgraded to this Linux version. You'll get a notification, right? If you have set up for notification, you'll get a notification. If it is a software that you have subscribed to, and you will get a notification saying like, we put in this new release, and now you can use these new features. So those innovations are coming automatically to us. We don't have to do anything. No maintenance, no upgrades, right? And also these are very, very easy to do it, because in the cloud it is multi-tenant. When you say multi-tenant, so there is one server, there are 4 people using it. Because of the virtualization, it will look like you're using there are 4 servers out there. Actually, you have only one server, and it's all virtualized. So this virtualization, you can also call tenant, like, this is like an apartment concept. You have 10 apartments in one building, right? So each one is renting one, and you will not even know. It's like you own a house out there, right? And because it is a multi-tenant, it is easy to upgrade. It is easy to maintain. How? So for example, you have 4 different servers. And if there is a security patch that comes in, you need to be applying those 4 servers these security patches, right? So there is a new version of the software coming. You need to be upgrading 4 servers. Here, there are no 4 servers. There's only one server. There are only 4 tenants out there. It's all virtualized. So you just need to upgrade one server and all the 4 people got upgraded, right? That's what they call it is um, spread through a multi-tenant infrastructure. That's why it's easy to maintain, easy to innovate on the cloud. And most of the vendors that I have described in the previous slide, the major vendors provide 99.9% uptime. So when we say 99.9% uptime, it's approximately, I think, I'm not sure if you do the calendar, it's approximately 7 hours per year. 7 hours per year is the downtime that can take maximum. That is because there are few maintenance. For example, there may be kernel upgrade that you need to do that has to be done in an offline mode. They're working on zero downtime upgrades and patching and things like that. The same thing for hardware. So you just take one core out, you put another core in there, system is still up and running. Wherever they can do 100%, they are doing 100%. There are still resources out there which needs a downtime, right? So that's why they have that 7 hours per year, which is approximately 99.9% uptime is the service level agreement with the consumers. So when you sign up for a contract with any of the cloud providers, you look for this, the people who provide this 99.9% uptime. So we talked about the elasticity, auto scale, and things like that. There are 2 ways you can scale. You can scale up, scale down, scale in, scale out. So all of these you can do seamlessly with the cloud. Scaling up, let's say you had 2 CPUs and you are increasing so you are adding a better CPU out there, right? You have let's say memory, you just put a better memory out there. That's like scaling up. You can also scale down. Scaling in and scaling out, what you do is you add things in parallel. So that means you have 2 CPUs added, physical CPUs added. You're not upgrading the same CPU to a better version of it, right? I'm just taking the computer as an example, right? So they always prefer scaling out. When they scale out, it is like elastic. It can be shared across multiple users. If they scale up, then the sharing is less, right? So irrespective of that, it has all these capabilities. You can scale up, scale down, scale in, scale out seamlessly. That is the feature that gives us the elasticity. Okay, and then it is sustainable, right? It 10 times carbon footprint is reduced, right? How? Now, let's say let's take educational institutions as an example. Every college runs its own IT department. So there is a data center. There is a data center power involved. There is a cooling power involved, right? So it's going to consume more electricity. It's going to be producing more CO2. So if it's all consolidated, let's say it's all put into a data center in Mumbai, and then you have a DR site in Hyderabad, and then that's all you have. You have 2 data centers that are serving more than tens and thousands of customers, right? So let's say one college uses the data center in the daytime, and then the nighttime it's all sleeping, right? So you still need to be running the data center with the power for cooling, for all the other purposes. If it is in the cloud, Cloud as algorithms, it will automatically route the resources. When India is using the resources, US will be sleeping. When US is using the resources, India will be sleeping. So look at where the utilization is better, right? On the cloud, it's well utilized. That is another reason why they are able to provide these things on a cheaper model, right? It's all shared. That's why the carbon footprint goes down. It is secure. So this is a controversial topic. A lot of people think, hey, I have everything running in my data center. I have it in my control. I can go and see my servers. I can go and see my storage servers. I know the wiring out there. There is a network, switches, routers, everything I can see. My system administrator is sitting there and administering my servers. My network administrator is out there, right? They're all there. My security is out there, right? Now, I don't know where my data is sitting. It's too scary, right? It is sitting somewhere in Mumbai. I'm accessing it. I don't know what is that server that I'm hosting my database. I don't know the database that hosts my data. They give a virtual address and then I use it. That's all I use. I don't see it. I don't see my server. I don't see my storage, right? So obviously people were so scared of going on to cloud initially. But then they realized being on the cloud is more secure than being on your own data center. How? Take this example. You are protecting your house. You can put a webcam, you can hire a security guard, right? What else you can do, right? There are some security services that you can hire for emergencies. Not everyone does that. If I'm a small business with 5 people, or I'm a small company with 20 employees, or even 100 employees, I cannot do all these things, right? Now, all these security services are out there. For example, you are sitting in a multi-story apartment complex. You don't have to do anything. You leave that security to your HOA, House Owners Association. They are top-class people. They put in webcam everywhere. They have a logging system. They validate the login. Who comes in, goes out. There is a professional security agency. They validate. They take the tapes out and then run them and check periodically. We don't do it. You can buy a webcam, which is very cheap, put on your apartment. But you're not going to be doing all those things. Every weekend you need to check whether, right? Whether it is working or not, right? If the battery has gone down, right? We're not going to be checking all those things. Now we leave it to professionals, and professionals will take care of it, right? If you want to deploy a security system for your own data center, it's very difficult. Let's say, there are a few new models that are coming in. Hey, that feature is very good, right? Right now, actually, my bell rang. It said like someone is at my door, right? So that feature is out there, and I want to put it in. Now I need to change all my security system, and then I need to deploy that in my house, right? But if you give it to a professional, they will do this automatically, right? If that system is older, they will get rid of it. They'll put a new system. If another agency is providing a better service. Next year, when you renew, you change them. Nowadays, no contract and no contract security services are available. It will automatically alert them, and they will be alerting the police and law enforcement, and they'll be coming in here. So now in the cloud gets certification. Almost all certification they get. I don't know what certification is in India. In US, we have a FedRAMP. The federal government has a standard that needs to be followed. All the cloud vendors that we talked about previously, they all are FedRAMP certified. So now you tell me, where is it safe? Is it in my data center or in the cloud? Right? If you are going to some Tom, Dick, Harry cloud who is not certified, then you will run into a problem, right? We're not talking about that. We are talking about the standard cloud providers, like that should be in your checklist, and check when you sign up for a contract. Do they have 99.9 uptime SLA, right? Are they if you're a hospital system, are they HIPAA compliant? There should be something like HIPAA is a healthcare compliance agency that certifies. There should be something similar in India, like AMCI or something like that. So we need to make sure, based on the industry we are in, whether this cloud is certified. Most of these cloud providers, AWS, Azure, Google Cloud Platform, or Oracle Cloud Infrastructure, they're all certified on all these security by security agencies. We talked about the economies of scale, right? The reason why it is cheaper, because we pull all these resources and make it as a resource pool, right? That's why it is cheaper, right? If you do it for one person, and then if you do it for two people, right, the effort is little easier. And then if you do it for 10 people, much easier. If you do it for 1,000 people, the cost is going to come down. All the overhead that overhead cost is shared across all the consumers. Bigger the cloud, cheaper the services are, right? So it's all consolidating on these top 5 cloud providers, and they're all big already. And the services that we take from them has to be cheaper, right? Coherence. Another advantage of cloud is coherence. So let's say, like, they will be, in order to do this virtualization, in order to get this economies of scale, in order to provide you 99.9% uptime, it has to be coherent. You cannot have a Intel chip, and then you have another AMD chip, and then you have a NetApp storage, and then a Sun storage. If you have that, it's going to be extremely difficult. I'm not saying they don't have, but they will have a coherence of, okay, this pool of storage is from Sun storage. They buy it from Sun, and then they put it in there. Then they have another pool of resources that they buy it from a NetApp storage. Then they get the AMD CPU cores, or they get Intel CPUs, right? And they will have Oracle ERP system, and then SAP ERP system, and they'll have 2, 3. But they will not be having too many of those. Then it will not have coherence. If they don't have coherence, they cannot provide cheaper solution. The economies of scale will not come. The coherence is the advantage for the vendor, and also for us. If we need to scale quickly, it's easy. If you are hybrid, it's going to be difficult. Here, hybrid is slightly loose term I'm using. We'll talk about the hybrid cloud a little bit later, right? So quick deployment. Let me go a little faster. Quick deployment. Yeah, I said, like, all you need to do is go to any of these vendors. As we speak now, if some of you want to try it out, go to any of those websites and, AWS or Azure or Google Cloud Platform or Oracle Cloud. You go in there, put in your first name, last name, your email address, and then some of them will ask for your credit card, but they will not charge it because they all have their trial. You just log in and ask for some compute and storage. You will get it in before we end this session. That's the quickness that we get. It's not just for your personal use. If you are starting a business, you have a very good requirement. Like, you have, let's say, like, I need 100 CPU cores and then 1 petabyte of storage. And then I have 3 virtual networks, right? I want these. It's all the things that you need to choose from the list of values out there on the application, and then set some checkboxes and submit it. You will get that deployed before we end this session. That is the speed of deployment that we are talking about. Of course, we talked about the manageability, and then there is a term that they're introducing here called burst computing. Burst computing is for the peak, right? We will not be having this peak all the time. For example, you are a government agency, right? Or a central government or the federal government. You're trying to do your GST on so-and-so date. That system, the GST system, or your tax system, personal tax, income tax system, on that week is going to be peak. After that, it's going to be sitting idle, or it's going to be like, the workload is going to be less. So when you burst into that peak, you cannot be buying so many computers, so many CPUs to process that data, right? So if any of you are filing GST, you will know that on the day of filing GST, that system will be very, very, very slow. You should tell them to move to cloud. Cloud can scale because it is huge. There are some people using it, right? So the payroll systems will be running on a specific day or a specific day of the month, right? Approximately, like, let's say 20th of the month, payroll systems run. In another country, the payroll runs, let's say, like, first week of the month or last day of the month, right? Middle East has Friday holiday, right? Each country has a different holiday schedule, working hours. If you pool all these resources into one giant infrastructure, it will load balance, right? That's why that's how they are able to accommodate this burst computing. If we are going to do all of those in our campus, we are a tax software company, and we host that ourselves, right? April 15th, the tax filing day, we will crash. That week, we will crash. So we need to buy a lot of resources to accommodate that. Okay, we are done. We managed it. What do we do with that hardware after that? In the month of May, right? So that's why we need to be on the cloud. Cloud is infinite resource. If they are not able to accommodate you, there is a clause in the contract that you can demand a penalty for that. Because the very definition of the cloud is it has to be elastic, right? Okay, so we spend enough time on this. Why cloud computing? And if you don't believe any of these, there is one keyword, that is it saves money. Okay. Now, what are the different deployment models? Which deployment model we should choose? Okay. There are a lot of deployment models out there. We have only given 4 of them here, right? So the first one is called um, private cloud, right? Let me check on the time. I think we are running a little slow. Okay, on the private cloud, we are hosting all your computing infrastructure yourself and is not shared. So everything is owned by one organization, right? It is not shared with anybody. What is the advantage? They claim that the security and control may be high. Security, we already talked about how the security is not better if you own everything yourself, right? Um, so the security and control is highest while using the private network. You're using a private network, but why is it called cloud? Right? This looks almost like an on-premise solution, right? That is like, you manage everything, your IT department. Here, it is your IT department. Everything is dedicated, but it is still sitting in the cloud. It is still sitting in Amazon, AWS, or it is sitting in Microsoft Azure or Google Cloud Platform or Oracle Cloud Infrastructure. It is sitting in one of those infrastructures. But you're not sharing. The whole hardware is dedicated. There is a pool of hardware that is dedicated to you. It is not shared with anyone. There is no multi-tenancy out there. You are a single tenant. And you have an exclusive private network. Network is not shared. Resources are not shared. Fully dedicated. That's called private cloud. It's going to be very expensive, but you have full control over it. Nobody is sharing. It's like, I want my single family home, right? I don't want to share with anybody, right? So for those, the solution is private cloud, right? The next one is community cloud. Let's take, there are few people working on a project, some cancer research, right? They all want to share, but they don't want to share with other businesses, right? For example, educational institutions. There may be software companies, manufacturing companies. I don't want to share it with anyone. We want a separate exclusive cloud for cancer research, right? A community cloud is shared between organizations with a common goal or that fit into a specific community. That's called community cloud. The next one, very popular one, is the public cloud, and it is cheaper, right? This is rendered over the internet. It has to be over the internet, right? You should access. There is no private network for you. This is through internet. Access is through internet. Whole computing infrastructure is located on the premises of a cloud computing company vendors that offer the cloud service. So everything is sitting there. You have your devices like mobile devices, laptops, desktops. That's all you have. Everything else is sitting there, right? That is public cloud. So whatever the characteristics that we talked about initially, we were mostly referring to the public cloud, right? Now, see, I already have an infrastructure. I have a company, there is a manufacturing in it. I'm a textile manufacturer, or I'm a um, automobile manufacturer, whatever it is. I have my IT department. I have everything set. I have my enterprise resource planning software. I have my HR software. I have my finance software. I have my supply chain software. I have everything out there. Now you are saying this is cheaper, more reliable, more secure. Okay, but I don't want to go everything, take everything and put it onto the public cloud, right? That is the reason why they came up with this solution called hybrid cloud, right? It can be multiple types of hybrids out there. You can still run everything here. And then if you want to do some simulations on the peak, I'm a tax software company. I will have everything here running. On the month of April, I will bust to public cloud, handle all that workload out there in the public cloud. Once my peak period is over, I'll come back. Right? So I'm a researcher. I will do everything in our university data center. And then I have a huge test that I need to run, simulation. I have petabytes of data. I need hundreds of thousands of cores of CPUs are required to simulate. Then I can burst to the cloud, go and run my test, see the results. Okay, I didn't get my results that I like, or no improvements. Then I come back to my university system, keep working on it. Now I'm ready to test. Remember, petabyte of data, hundreds and thousands of cores of CPUs are required. The universities are not going to provide that. So I now burst to the public cloud, go to Amazon, Microsoft Azure, Google Cloud Platform, do my simulation, test it, see the results, come back. Right? So that's the academic example. There may be examples out there like that for manufacturing. Right? So that's the hybrid cloud. So there are other types of cloud. I don't think we will have time to go over all of them. So there is something called multi-cloud, and there is so multi-cloud is like, hey, I'm a business. I have a HR software. I have financial software. I have CRM software, right? I have some genetic research software. So I want to, so Google seems to be cheaper. I want to take everything and put it into the Google Cloud, right? Then what happens? Google hides the price, or something happens to Google, right? So I can do, hey, ERP software is very good from Oracle Corporation. Financial software is good from SAP Corporation. HR software is good from Workday. So what I'll do is I'll buy this from here and that from another vendor. I can have all my different softwares running in different applications running in different clouds. So that's called multi-cloud, right? You can have multi-cloud. You can go on multi-cloud, and for example, you can have your online transaction processing. You can do it in Oracle Cloud because they are the database gurus, and then you can do BI analytics on SAP. So you can be on two vendors, and then you call that as multi-cloud. This is what they call, you don't get into vendor lock-in. So you always have, like, you have two vendors, but this requires a lot of challenges. If you're a small company, if you're trying to do this, you may end up paying more in the integration, you may spend more money, and you may introduce some security issues as well. If you're really a big company, and if you want top of everything, best of best, I want HR software from this company. I want analytics. I want a data cloud or AI solution from Microsoft, right? So you buy whatever is top from those companies, and that's what is the multi-cloud. But it may not work for everyone. If you're a smaller company, it's better to sit on a public cloud. Just go to one vendor who gives you the cheaper deal. You just pick it up and go to that cloud. Okay. So there are distributed cloud. Instead of putting all of them in the data centers, big data centers for the vendors. This is more on how the vendor is implementing it. So they will distribute it to multiple locations, and then they will also have some edge computers that can render your results fast and things like that. So they all fall under distributed cloud, and there are some poly cloud as well. So poly cloud is much similar to the multi-cloud. It is like picking best of best as well from each of those companies. Okay. One last topic before we can get on to some use cases. There is another category called service level based classification here, cloud service models. And depending on what is serviced, we can divide them into three broad categories: infrastructure as a service, platform as a service, software as a service. So this is just three of them. There are hundreds of such classifications out there. We have backend as a service for mobile applications, and we have a robotic services, AI services, data services, database services, so many, anything. So that's why I put something like everything as a service, right? So we cannot go over all of them. That's the reason why we are doing this. Three major ones: infrastructure as a service. The scope of this is servers, storage, network. If you are just taking these, I want server, 2 cores, 2 terabytes of storage, then I want this much bandwidth network. So you go to a IaaS cloud, but most of the vendors we saw, they all provide everything. Google is an IaaS, PaaS, SaaS. Amazon is in all the three, right? You go to the same vendor, but you ask for a different resource. If you're just getting the server storage network, then what you are accessing is the infrastructure as service. Who are the people who are going to be asking for these things? And normal users like us may not do that. It is like IT departments, the network architects. Those are the people who will be working at that level. If you're a developer, if you're a student, you will work at PaaS level, platform as service. What is given here? Operating systems, application stack, like, you'll have a Java J developer or, all the programming languages, right? Remember, in order for all those things to run, you still need the server storage network. So PaaS has to sit on the IaaS. Okay. But the consumers here, these are application developers, students, the researchers. All these people will be using PaaS service. And the topmost is the package software. This is your HR software used by HR administrators, students, employees, and more, right? So this package software. all the end users, any end user, most of us are definitely end users. Some of us may be the app developers, right? So most of the people are going to be falling under those categories. And each service model has to sit on the underlying model to work. So in order for SaaS, we need PaaS and IaaS. We don't need to know about those things. Those layers are abstracted, and you will not even know there is a PaaS and IaaS underneath if you are subscribing to software as a service. Let's say, like, now you go, so example, Google Docs, right? Google Docs, I'm a Google Docs user. Of course, it is free. We use it, but if you're a corporation, you need to pay for it, right? And you think like you are subscribing to that software, right? Or your email, right? You think you're subscribing to the software. Underneath, there is a platform, there is an operating system, there is a web server, there is an app server. All of them are running underneath. Underneath, you have all the other infrastructure. You have server, storage, network. In order for them to be running, you need physical infrastructure, your data center, power, everything. But that's not given as a service. There are services like data center as a service, right? But we're not going that deep here. So that's why anything can be a service. That's why we call everything as a service. The enabler for everything as a service is SOA. You need to think in the service-oriented architecture. Anything that you develop at the hardware level or software level, you make it as a service, okay? If you make it as a service, you always think there is a consumer who is going to consume this, and then they're going to pay for it, and I'm going to measure. For example, there's a credit card authorization service, okay? I just develop a software, a small software, right? And then you call it, it takes all your credit card information, send it to the credit card agency, authenticate it, and then process your request, gives you the confirmation. You develop that, put it onto different clouds and make it available, right? That's a service. That's a medium-sized service. There may be a bigger service. There may be a service which is very small. What is the time service? What is the time in Europe? Or what is the time in UK? A service, time service, right? You develop a service and put it in. So think in terms of developing services. Same thing for hardware. How can it be measured? If you process 10 credit card authorizations, you pay me 10 cents for each credit card authorization, right? So measurable services. So there is another thing called edge computing. Why I put that in here is there are multimedia content that is getting delivered today. It will have some latency issues. Now, the cloud is also getting an edge. So some of the processing is sent to the edge of the cloud. It may be dedicated edge devices or some of the devices that we use as consumers, example, our mobile phones. So leverage some of the computing and data processing power that we have on our devices and leverage that. And put edge computers on the peripherals of the cloud so that it will be rendered, like, if you are using this particular service from India, then it will be served from an edge computer out there in your local data center, right? So And that's an emerging trend in order to improve the performance of the cloud. And on the right side, you have what are the components for each of those types. On-premise meaning today, if you're not using the cloud, that is the reference point. On-premise, everything is in our data center, network, storage, server, virtualization, operating system, middleware, everything is there in our premise, right? So we are comparing that with each of these models. If you want to go only use the hardware and keep all your software on top of that, then you go for IaaS. You get network, storage, server, virtualization, but everything else you put them on top and you use it, you manage it. That's still possible. Or you can go one level up. I don't want to deal with any of these infrastructure piece, like including the middleware, runtime. I just want to take care of my application that I write, and I want to keep my data. I own the data, right? I don't want to put it into the cloud. You can do that in the platform as service. On software as service, now you are trusting someone, you are giving everything out to the cloud, you are accessing them through a browser on the internet. Okay, let me go a little faster. Let's go into how the specific topic of education. So I will not go line by line. I will just touch on each slide, right? So cloud computing can be used for every dimension of education. There is a dimension from teaching side, and there is a dimension from students and research side, and there is a dimension that is coming from the administration side, right? Each of them have different benefits when they go to cloud. And then anyway, I'm going to elaborate in the later slides. I'll go straight. This is one example that I wanted to give. There is a rural school in Spain, right? The way they were doing teaching was each village will have one school, right? And one teacher, right? That's all they will have. Everybody else are experts, right? If he's a science teacher, he's an expert. He's not dedicated to that school, right? And let's say like, PE teacher, they are also an expert. They are consultants. They are not attached to the school. There is only one teacher sitting in the school, and it has a little bit of computing there, a couple of servers out there, right? And they do everything dedicated. All the resources are dedicated to them. And what happens is these resources, they come here. The PE teacher has to take a car, go to another school and coach football. The science teacher finishes in the one school and then goes to another school, drives to another location on the same day or another day, and then they treat. So they're not able to effectively use the resources. This is the human resources as well as the computing resources. For example, whatever the resources out there, the two computers out there, but that cannot be shared by another school out there, right? Now, what they did was they did this as a project. HP Labs funded this project. They took an open source cloud, right? They call iCloud. This is not Amazon cloud. This is not a Microsoft cloud. This is not a Google cloud. This is an iCloud. It's open source. It's free for everybody. They took that and they put some of the HP servers out there, and they created a cloud, right? And then the browser, if you look at the bottommost icon out there, we have Firefox, which is the free. They put all the lightweight software out there, and then they created a cloud. Then what happened was all these resources that are from these small schools, they're all pooled together, right? There is a resource sharing already happening. Then these experts, right? For example, the science teacher need not travel to all these schools. They can just be on the cloud and teaching from there. No teacher rotation. And the experts visit, it's easy. They're not traveling. Neither the teachers nor the experts. If you're bringing an expert to give a demonstration on a specific topic, and they need not travel either, right? Highly resource sharing was happening, and that was working, and now they are expanding that in Spain. Okay, that's on the rural schools. On the higher education, look at these two examples. These two students are sitting out there, and then they want to test, simulate a network, massively parallel network. They have come up with a firewall algorithm. They want to test it. All they're doing is they are using only one computer out there and testing it, whereas a massively parallel compute resources are used on the internet, right? On the right side, you see there is a particle accelerator that produces a humongous amount of data, and no university can process that data. They are giving this data out. This is a nuclear research place in UK. They are giving this to all the students, but you need hundreds and hundreds of CPU cores to process this data. All you need to do is you go to the Azure cloud and then run this, process it, come back, and then validate. Okay, if you need to tune your algorithm, if you need to tune your code, you do that. Again, go back and test it. You'll be charged only for the time you are testing it. There is no way a university is going to give you a compute resource of tens, hundreds, and hundred thousands of CPU cores. Okay, so I'll skip this and then go to this important slide that I want to talk. Stanford Medical created a service called Genomics service. They started this in 2014, and they wanted to focus on 4 major disease areas: childhood mystery diseases, familial cancer, familial heart disease, unusual reactions to medications, all related to genetics. What they did was they were able to come up with all these algorithms. They had this data out there, but they didn't have the computing resource to do that, right? Then they went to the Google cloud platform and then created something called Genomics service. So it is the Google Elastic Cloud, and since it is related to healthcare, only few providers can provide this, which is fully certified. All the government agencies has to certify that the healthcare data can be put to this cloud. So they found that the Google Cloud qualifies for that, and then they joint ventured with Google. They called it as Google Genomics. This is a joint project between Stanford and Google. Now, what happens with this is, so this is the UI of that Genomics cloud, right? You have your genomics data, right? The local storage. You take it to the cloud storage, put it in the cloud storage. The red area here is the user data. So what you are doing is, if you are a clinician, right, you are taking your patient data, putting it in there. And then the green one is the public data, from Human Genomics Project. And there is a control data. This is coming from hospitals. It will have personally identifiable information, that is the patient information, but that is controlled for some researchers. So you have 3 sets of data. Then you can bring in your own patient data. And then, so in the bottom, you will see that you will load this genomic data. You will open this genomics data. It is petabyte of data. The moment you click on it, it opens up as if nothing happened. Not even a hourglass that shows up. Petabytes data, bytes of data, because for each patient, genomics data is going to be in terabytes. Then you tell, like, I have a patient, 32 years old, and then smoker, right? And a Caucasian, right? And then you choose all of that, and then say, like, okay, give me the cohort for that. Then it will go and filter and then bring in of all this, like 23,000 patient data. It will bring down 115 people who have genetic similarity with this particular patient. You can also share with other researchers who are doing research on that and ask them, collaborate in the same platform and ask them, hey, are you doing any research on this profile of patients? And then you can also find out whether these 115 patients participates in any clinical trials on any of the new upcoming medications. So they were successfully do these kind of activities on this platform. So it can vary from you are solving a rotating teacher problem in a rural area to a research project that involves petabytes of data for genomics. So cloud can go from this end to that end. So sky is the limit for that. And one last thought on this. A lot of people say, like, oh, all these are good. What about digital inclusion? Or are all the people who don't have this capability, how are they going to come into this? With the cloud, all you need is a simple 2-core, 16 GB, 2 gig RAM device. Government of India introduced this thing called Akash, the one on the top, like a tablet, that costs 3,000 rupees. So this Samsung Galaxy is 7,000 rupees, right? There are projects that talks about 1 laptop per child. Every school-going, college-going child should get a device like this. Once you have this device like this, all these major vendors, Google has something called Google for Education, Oracle has Oracle Academy, they have a free tier for the students. AWS has AWS Educate. You see that how much of the free thing that they give. And Azure has something similar. And if you are a full-time student, you have a college ID with the EDU, you get 12 months of free resources out there. And as long as you're a student, you can keep extending that till you graduate. So that is how we are going to bring in the equity, and that's how we are going to solve this problem of digital divide and digital inclusion eventually. Okay. Unfortunately, we don't have time for cloud. We don't have time for Q&A. Cloud is for everyone. Cloud is the democracy. Cloud is the way to go. Thank you, sir. Back to you.
Thank you, Kandasamy Mohammadi sir. Very nice and soft-spoken way of introducing cloud technology to our international conference. Thanks on behalf of our college and the trust. You are given elaborate discussion related to cloud technology, why we should go for cloud technology. I do have some few set of questions to ask, but unfortunately,
Sure.
the session has extended to a larger extent. And do we have any wide publicity related to this cloud usage, and what level of statistics of people are using cloud nowadays?
Cloud is at present, I would say, like nearly 20% adoption at this point. So remember, people are going to be a little scared in the beginning. So that's why I was talking about this hybrid cloud model. So this is the model they are using right now. They're keeping most of the things in their data centers, slowly going for peak work they're going into the cloud, right? And then some of them are doing private clouds as well. And then slowly they are getting into the public cloud. For example, HR software, right? You can easily put that onto cloud. But financial software, banks, you will think twice, but eventually all of them will migrate to the cloud. I would say like around 20% has already migrated to the cloud.
What's the scope for youngsters you are predicting as far as cloud technology is concerned?
Next 5 to 10 years, if you are not in the cloud, you are not in the right place. Period.
Thank you.
Cloud computing has to be brought into the regular curriculum, because irrespective of what department you are in, mechanical engineering or civil engineering or biotech or whatever it is, this is like how we used to learn typewriting in old days, right? So it is like that. Like, everybody should know the cloud. You go there, log in today into any of those 5 big vendors. They all are free trial period and free forever as well. So for students especially, they have a 1 year free, which is extendable. Go and subscribe to it, play around, get used to it.
Very, very, very nice of you, sir. Excellent presentation, giving a larger amount of scope to youngsters. Thank you for keeping in mind our time constraints. We are winding up this session. On behalf of, once again, on behalf of our college and our trust, heartfelt thanks to Kandasamy Umabadi, sir. Excellent presentation, sir. Thank you so much, sir.
Thank you so much. Thanks everyone for your time.
Thank you, Palaniappan sir, and thank you, Kandasamy Umabadi sir, for excellent session.